find the domain of this function. We know that whenever there's a radical, that the radicand must be non-negative, meaning that this must be greater than or equal to 0. We can factor the left side into 1 plus t times 1 minus t greater than or equal to 0. And you can see that our critical values are going to be -1 and +1. When we substitute values, well, let's write this down here. We're going to have 1 plus t and 1 minus t. When we substitute values smaller than -1 in, we're going to have a negative off to the left, a positive in the center, and a positive to the right. When we substitute values to the left of -1, like -2, we'll have 1 minus a -2. We get +3, so that's positive. We're going to have positive in the center and a negative on the right. And we are interested in the product of these signs, so multiplying downward we have negative, positive, and negative, and we are interested in where it's greater than or equal to 0, which means it's in that middle section including those endpoints. So our solution here will be the interval from -1 to +1, including both endpoints. Now we're asked to find the domain here in interval notation. We notice that the numerator cannot be 0. That is a critical value. We also notice that -1 is a critical value also. And we know that when we have a radical, that the radicand 2x over x plus 1 usually is greater than or equal to 0. So we're going to set that to be greater than or equal to 0. And our critical values, as we've already stated, are -1 and 0. So let's see what happens on each of these in the numerator and denominator. Here's 2x, here's x plus 1. If we choose values that are negative, we will have negative in the first two regions and positive on the right. If we choose values smaller than -1, we will have a negative on the far left and positive in the middle and on the right. And we're interested in what happens when we divide these signs. So positive, negative, positive. We're interested in where this is greater than or equal to 2 or 0. So our answer will be off to the far left and off to the far right. But we cannot include the -1 because that's not part of the domain, but we can include the 0 there. So our solution set here is from -infinity up to -1 united with 0, which we include, on up to positive infinity. Now I'd like to do this problem for you in a totally different way. We're going to still look at this, but we're going to try graphing. We're interested in where 2x over x plus 1 is greater than or equal to 0. And if we were to graph this 2x over x plus 1, it would be a rational function. We'd look at the numerator. We would see that at x equals 0, we're going to have an x-intercept. We would see that in the denominator at x equals -1, we would have a vertical asymptote. If we substituted 0 in, h of 0 equals 0 over 1, which equals 0, and that becomes our y-intercept. We look at the degrees, and the degrees are the same, so the ratio of 2 over 1, y equals 2 over 1, becomes our horizontal asymptote. So if we graph all of this, let's start with the x equals 0 x-intercept, the x equals -1 vertical asymptote. Let's do the y equals 2 horizontal asymptote. You will see that we're going to have our curve very quickly drawn right in there and then up on the top left. The question then becomes, where is this greater than or equal to 0? You can see that it's above all the way over here on the left, so everything to the left of -1. And where is it above again? Starting at 0 and everything to the right, which is the same as the same answer that we had up above.